Okay, now it's better with the microphone open. You can listen me. You can listen me better. Okay. Good afternoon, everyone. I'm very happy and honored to have here my old friend, because we met for the first time in 2003 in Lyon when I worked with Robert Laurelli in Lyon, and he was a postdoc in Avignon at the National Research Council in France. And Jagannath Aryal is born in Nepal, and after postdoc in he worked also in Netherlands, if I remember right, before to come to France. Later postdoc in France, and later now he's professor at the University of Melbourne in Australia, ranked as the first university in Australia and at the 13th level in the world. And I'm very happy and honored, because Potenza is not easy to reach. It's not a low level of accessibility, but he was in Europe, and he messaged me several months ago saying, okay, I planned this travel because it was like a conference in Athens, another in Split, and now we have to go to Hong Kong for another seminar. And he found 3 days to spend in Potenza, where we shared several ideas for new researchers, and also other opportunity to have a cooperation together. And I'm very happy that I can stay with him a few days. After 21 years, but I hope that we will meet again, not in 21 years, because I'm close to 60. Probably, I don't know if I'll be still alive in the next 21 years. Probably, cross the finger, but who knows? Cross the finger, but who knows? I hope to meet you in 1 year, in 2 years, no more. And also I asked to several colleagues and friends to participate to the debate. Also, first of all, to colleagues of physics, because we are discussing also about image classification, and Giuliano Liuzzi and Guido Masiello, they work in these activities, and also involved in global environmental changes, and probably very close also to the topics of application that you can show this afternoon. And also asked to Maria Danese here, my own PhD students, a lot of time ago. Now he's first researcher at the National Research Council here, close to Potenza. And also I asked two other colleagues from other university, Dionysia Perperidou from University of Athens, because also his background is as surveyor at the beginning. This means that he has also a great, it's very close to the field of Jagannath presentation. Sabrina Lai, okay, several projects together from University of Cagliari, and also Dessislava Petrova-Antonova for the GATE University in Sofia, in Bulgaria, and Gerardo Carpentieri from the University of Naples. Okay, but there are in this room also other PhD students, and we'll also say thank you for the current director, Professor Masiello of the School of Engineering, is here and participates in his work, and the future director, Benedetto Manganelli, because we will change the director in 1 month, more or less, and they are here to participate to this seminar. Okay, I don't want to waste more time, and I ask Jagannath to have the presentation. Jagannath, the floor is yours.
Thank you. Thank you very much, Professor Murgante, and I'm very delighted to be here in front of you to share some of the work that we have done in Earth observation space. When we say Earth observation,
from the remote guest, do you see the presentation? Okay.
We see also the notes, the next slides.
So you see the notes as well in the slides?
Yes, also notes.
Yes.
You look at the note. Okay, you have to switch.
You can close.
No, vai là. Vai su switch. Dici no, converti il rettoratore questo.
Yeah. How about now?
Okay, perfect.
Okay, you can start.
Thank you for being here. And I'm delighted, as I said, to share some of the works that we are doing. And we are in the digital age. And it's all of us are experiencing whatever data sets we use, we convert into digital format. So the talk will cover on where we are at, how we are tackling all these digital issues. I will be providing some representative examples from urban feature extraction, in the spatial planning. For example, Earth observation or remote sensing data sets are so useful, given we can monitor and sense our landscape without intervening. So remotely we can monitor. But the information that we extract from images can be used for planning, making decisions, and supporting policies. So within that, I will be discussing this talk. And I will be introducing, it will be very interesting to you, what is University of Melbourne, where it is, and where it sits in the world ranking, all those things from Australia. And the faculty and department where I belong to, in the structure that I will share. And the research group that I lead, in the PhD projects students are working on, that I will quickly share. And as I say, digital age in science of where, that I will show you everything that's happening somewhere, either it is a celebration or incident or accident, whatever is happening. We have to characterize that location and get the intelligence of the location. So for that, we use computer science. We use AI tools. So engineering and IT, they meet together to solve these problems, and to better understand, and to prepare the future leaders in the research.
Probably
and
better if you can stay close to also to be seen if you are sitting, because
Okay. Sitting is good.
yes,
Okay.
probably there is then problem with the
Sure. Sure. And then I will be introducing with this requirement of digital age and the things that we are tackling in Melbourne. What we have done is we proposed a new course called Master of Digital Infrastructure Engineering from 2023, and I am the coordinator of that course. And what I will present is what we do in that course, and we are very open to collaboration with the world. And that collaboration will help to tackle these digital problems that we are facing. And I will show you some of the samples in practice, how digital infrastructure engineering is being used. And Earth observation and spatial planning is the focus of this talk that I will lead. And urban feature extraction with representative examples of urban trees and vegetation, as well as urban building footprint. When we can develop an accurate inventory of urban trees, urban vegetation, and buildings, then we can make a balance of infrastructure that we have to create for the growing population. And we have to make a balance of environmental sustainability for our future generation. We want to hand over our cities to our future generation in an environmentally friendly way. But we need to accommodate our growing population for the shelter, for the food, and for other infrastructure. And trending intelligent measures in urban future extraction, spatial planning, I will be covering. What are the trending measures from computer science? How we can work together with computer scientists or IT people to tackle this problem. As digital, the backbone is computer. When we say digital, the backbone is computer science, the algorithms, the fundamentals. But if we can't make sense to policy, make sense to people, then it will be abstract. So we have to translate those abstract into applications. Spatial planning is that's why key. Location intelligence is very key. With all these challenges and opportunities, both where we are at and where are we heading, that I will be presenting. And the way forward in the digital age is a digital infrastructure engineering in our thinking, which I think you also agree with that. And we join the hands together and go together. With that, let me present, and I'd like to thank the online colleagues who are here and dedicated their time to listen. We'd like to welcome you, and I again would like to thank Professor Murgante for this opportunity so that we know each other and we can work in a more collaborative way. Not only between you of us, many of you can join for that collaboration. Thank you very much. So let's start with the university. It was established in 1953, one of the world's 13 finest universities and #1 in Australia, and 160 years of academic leadership. And the faculty I'm from is Faculty of Engineering and Information Technology. It has 400 plus PhD qualified researchers and teachers, 300 students, 700 master's level, 900 graduate research. And we have dual accreditation with Engineers Australia and US. As many of you know, US is European accreditation body. We invite colleagues from US to Melbourne for a week, and they review all our course, like lecture materials, to assignments, to everything, and they provide the credit. That means our students, when they graduate from masters within this university, they can come to Europe and work. They don't have to have one of the equivalents or some sort of certificate. It's because this accreditation help them to work when university is covering accreditation in European countries. And Engineers Australia is another professional body with that accreditation. We fulfill the requirement of industry, how the industry is heading, how the market is heading. We not only do the research, what we do is we certify the industry. And then cutting-edge interdisciplinary research and work with a range of partners from academia, government, and industry, that is our focus. The department that I belong to is, you can see infrastructure engineering in the center. We create infrastructure, we monitor infrastructure, their health. For example, we have aging infrastructure, 2000 years old infrastructure. How to quantify their health and how to support them. Like our health, infrastructure are also having heavy shifts. But how we know that, how to monitor and how to support, that is the core of infrastructure engineering. For that, the base is geomatics, which is spatial, and the other wing is civil engineering, and other is environmental engineering. These three will compose the infrastructure engineering. And there are different groups, small research groups, they are working within this, like structural materials and built environment to geomatics engineering. The department has 40 plus faculty, 60 plus research staff, 200 plus PhD students, and 1,000 postdoctoral students. And as I said before, University of Melbourne and Faculty of Engineering and IT ranked #1 in Australia, #1 this year. Since last 5 to 6 years, we are sustaining the #1 position. And the geomatics engineering is where I'm coming from, and I'm doing the research. So geomatics is spatial engineering and IT. When we combine the computer science expertise with spatial activities, then we say geomatics. We use science and technology to measure, model, manage, predict, and visualize our world from the lens of location intelligence. As I said before, location intelligence is how to characterize the location where something is happening. Accident, incident, celebrations, whatever it is happening, then we need to characterize it, we need to support people. For example, we can think of a bushfire environment, we can think of a landslide, we can think of earthquake, how to deploy the resources optimally, and how to support people, and how to send the rescue on time and efficiently. That's a challenge if we know, if we can characterize. For example, I was in Athens, let's say, and I received in the middle of the night, oh, there is an alert, right, of the bushfire. So those sort of things, how we can support. That we need to know the location, the geography. And the digital infrastructure is all about observation and spatial planning. We scan, or let's say monitor our landscape in different scales, multiple scales, right? So from, let's say, agricultural farm to the region. If we are talking about crop modeling or crop mapping, crop health, then we fly the drone and we go to agricultural farm. But if we are monitoring the bushfire, then we need a satellite. So different types of platform can be used to scan our Earth. And then we draw the information from images. Likewise, if we think of 3D cadastre and urban land administration system, we support people with the property management. We need to have an accurate delineation of boundaries to support them. And high definition real-time maps are another maps, digital maps that we support people. And another area is analytical and visual design support services that we do in automated environment for dashboards. Like, for example, we can create dashboards for the policymakers, for the politicians, for carbon, sustainability, resiliency, disaster management. These are the challenges that we need to go deeper. And business decisions in urban analytics is another area with VR, AR technology that we can do. And autonomous systems, as we are experiencing with autonomous vehicle, the importance of location intelligence is becoming more and more challenging to us. How the vehicle will scan the environment, there is driverless cars, and we now ride with the driverless cars. So we need to have a very robust navigation system. And this is a research group that I lead, Earth Observation and AI research group within geomatics, and these are the members that work with me. And they have different projects. They are looking into urban feature extraction, bushfire security classification, informal urban growth, individual tree segmentation using 3D LiDAR, point clouds, and field boundary extraction using intelligent methods like deep learning and machine learning, and urban sprawl management. For example, potential next 50 years, or 100 years, or 500 years, 1,000 years, how it will grow. Like that, those projections is a problem that CCTV and land use and land cover classification, how we accurately map those. These are the projects that we are looking. And as you see, informal urban growth is another interesting area in the global south. When the people, they have, let's say, from either natural disaster or conflict or any other thing, they have to leave their original place and they have to go into the new area where they don't know anyone. What they do is they put their tent and they don't care about ownership of the land, they just stay there. So if you look in Mumbai in India or in Colombia, in different countries, this is happening. Not less than Europe, but more than global south. So we have challenges of the 21st century, climate crisis, depleting natural resources, society falling apart, military conflicts, and nothing of this is new. We all know this, but how to tackle it? All of this needs to change. Right? We need to be thinking for new. We can't have a status quo. We need to support people, we need to educate people, and we need to let them know that, yes, we have challenges, but we have opportunities as well. And let's have a look at what the challenges are. Hopefully this will display properly here.
Hunger, poverty, winning the fight against disease, urban development, reforestation, careful use of water resources, and the development of smarter land management, intelligent transportation, environmental challenges, building resilience of our cities and infrastructure. They are all happening right now, somewhere. As our planet is becoming more crowded, the demand for diminishing natural resources is growing. Income gaps are widening, and people are being left behind. Geographic location and information about these locations shows us where social, environmental, and economic conditions occur. Where are people at risk from rising sea levels? How do we protect the people living there? Where is disease occurring? Where might it spread to next? How do we contain it? How many hectares of forest are there? Where are they? Are we managing them sustainably? How many people do not have access to good health care, education, fresh water, or regular reliable public transport? Geographic information can show us when and why things have happened in the past. It can show us why and where they might happen in the future. And if we know where, we can take action. Geographic information about people and the planet makes the invisible visible. It helps us to make better decisions and make better use of our resources. By collecting geographic information, we can identify patterns in human and natural processes, predict the outcomes, and take preventative measures where and when needed. Reliable and authoritative geographic information provides the framework for measuring, monitoring, and achieving the Sustainable Development Goals, improving people's lives, and protecting the planet. Because everything that happens somewhere, and knowing where is the key to making good decisions and policy.
Right. This shows that the purpose of showing that video is the importance of where. Anything that is happening somewhere. And if we look from different angles, how we can characterize that where. Science of where is all about supporting people. But that we thought, okay, why not we develop a unique master's course that can tackle this? That in Melbourne, 2023, we started Master of Digital Infrastructure Engineering, a new course between engineering and IT. And this particular course is looking into the students that will be able to develop the skills in sensing, managing, analyzing, and communicating data, monitoring our environments, using digital technology to improve processes. They can specialize in different areas because we are not preparing people on AI, business, cities, construction, energy, land, transport, water from our degree, but the importance of digital things on the location, importance of location intelligence in every display is there. And our trained people can further help to the specialist people. And let's have a look at some practice, what we do with digital infrastructure engineering practice, like assessing the impact of our wind farm development on nature and people, and how this is balanced with the benefits of particular locations and with particular design. Creating a digital construction workflow before sending the engineers into the field. What we can do is, in the digital environment, the engineers can make a plan while they are in the office. And then what they can do is they can go out there in the field and make an optimal site selection, optimal construction. Likewise, emergency and disaster management for the people, as well as for the deployment of resources that we can do digitally at first. And then managing public transport using data streams of vehicle locations and passenger counts, social media and infrastructure data. For example, we can employ in our digital platforms, Instagram, Facebook, Twitter, any data source. Polytechnic, human are the best sensors than any sensing technology that can be captured and support back to them. Likewise, urban green management in smart cities. Spatial planning is all about managing urban greens. So we want to hand over our cities with greenery to our next generation, right? But that we need to monitor the trees and we need to map them and we need to water them. The trees are so good that they help us in breathing and water runoff and all those things. Likewise, autonomous vehicle that we're experiencing, how we can do with digital infrastructure engineering. So this course is 3 years full time, and we have a collaboration opportunity here. And if you are interested from your institution, we can do this like 3.5 years, 3.5, 1.5 years. There is a collaborative model for Indian institution that we propose, which can be proposed in European institution as well. So this is on campus, available to domestic and international students. Start year is February intake and mid-year intake is July. And we have the requirements like an engineering major from the University of Melbourne, or an engineering degree or major from this university or any other university, and any undergraduate degree. So how this works, the collaboration model is 3.5 years at the home institution. If you have a 4-year undergraduate degree, that undergraduate student will do 1 semester as a study abroad arrangement, so the partner pay in Australia. So they will finish their 4-year degree by doing 1 semester with us. And the students get their degree and then apply to our Master of Digital Infrastructure Engineering. We give them credit for 50 points. 50 points means core subjects, right? And they do our degree in 1.5 years. So basically 3 years degree or 6 years part-time can be done in 1.5 years. 100 points block credit, for which we need to have access to your 4 years course plan. The starting point is mapping the subjects, how we can exchange and give the credit to students. And we need to map out undergraduate syllabus and see what subjects you can take in the 0.5 years, which is 1 semester. So this is the model I propose to other institutions as well, given this is a new degree or digital infrastructure. So this is publicly available, and you can go with the handbook, this particular link, and then click on that or search my name. I'm the coordinator that you can see, and you can write me an email. This is publicly available information. And the sample course plan here, what we teach in different years. Year 1, our Bachelor of Science or Bachelor of Design in semester 1, semester 2, and year 2, year 3. So all the sustainable infrastructure engineering, applying digital infrastructure, imaging the environment, engineering risk analysis, this we teach like that. You can get all the subject information. Right, with this introduction of the degree and the university and the department, now let's go to a bit serious items on the research. Inventories of urban planning. How we need to make these inventories, for example, for trees, for buildings and things. So global problem is there. We are experiencing that urbanization is growing. 50% to 70% of the population by 2050 will be in the urban areas. People want to get the facilities and opportunities in urban areas, and the villages are left behind, and we need to manage the people. 2050, this will be the scenario, the projects. Rapid growth in urban population, a globally recognized challenge, is hit hard by the current economic crisis. Housing crisis, unaffordable houses, accuracy of urban inventories have become important more than ever. So for that, we propose here Earth observation, EO and AI, artificial intelligence, to develop these inventories so that the policymakers or the politicians can do efficient decisions to support people. So what are the importance of urban inventories in planning? Sustainable city planning and optimal land use design are becoming challenges, considering environmental sustainability, urban growth, and citizen science. So this is well understood and accepted by everyone. So we can use Earth observation images. Given the remote access, we can have prepared accurate inventories of buildings, trees, vegetation, and their varieties. There is a clear gap in knowledge in developing the spatial ecosystem of existing urban feature management. So when I say ecosystem or a spatial ecosystem, we need a conceptual framework, we need data structure, we need all these, and then develop operational framework. So that's what we propose. But that operational framework for urban infrastructure and sustainable city planning using Earth observation images and intelligent approaches is needed. So when we look into Earth observation, we know about this space, airborne, and ground-based. So we scan our Earth from the space, we scan our Earth from airborne and ground, depending on the application. As I said before, if we are looking into individual farm or crop, we go with ground. Or if we are meditating for, let's say, big regions for bushfire, then we go with the space. So Earth observation can provide insights into phenomena that are otherwise impossible to measure. We can see in different products that we can have. And not only new, this has started from 1957. If we look back into the history from Europe, it was started and we are developing new knowledge and new technologies, and we are going into, in 2020, private sector special satellite missions. From Netherlands, for example, ICI is a private sector space company. They are launching the satellites. And the machine learning is evolving, computer science is evolving, and with the Earth observation data sets available in different spatial and temporal regions, we can extract information that provide insight to us. This is an example, not only in Richter, from the local government in Victoria, Melbourne, the Victorian government, they already started. We use machine learning to map the tree density of the cities, in densities, medium cities, sparse cities, and the healthy, unhealthy, or stressed, unstressed vegetation are provided. And the private sector is also in there. Deep learning with Earth observation for geospatial industry, the near map is using this, and automated insights we can trust on this. The use case of near map to map the vegetation in the cities. Having said that, there are challenges for Earth observation and intelligent ecosystem, and we will be tackling in different laboratories with challenges. We do have limited labor training data. It's very hard to have a ground truth. We have costs of dimensionality, we have spectral spatial complexity. So what we see from the senses and what we get in the data is not accurate. We can get the data sets with uncertainty, we can get the data sets with error, but we need to develop algorithms and tools to tackle those uncertainties and those errors. And class imbalance and rare events are there. So how to have the accurate classes? Robustness to environmental variability is there. Explainability and interpretability is another challenge, where we need help from computer science, how to explain and how to interpret the things more accurately. And real-time processing, I would say near real-time processing and resource constraints are there. The time delay, how we factor in. For that, the recommended concepts of framework should start with data standards, spatial data structure, completeness matrices, relation to construction standards, and application to environmental sustainability. So the aim of the framework is to integrate multi-source data sets such as cadastral, property, and geocoded national address file to facilitate a seamless workflow in urban planning and construction. It is all about how we manage the digital infrastructure. And this is an example that I published with my collaborator, my postdoc, Intelligent Methods in Urban Tree Vegetation Mapping. This was published in Nature Scientific Report in 2023 that you can download from this link, and where I use land use and land cover performance modeling using machine learning algorithms, a case study of the city of Melbourne, Australia. In this particular study, what we have done is we propose accurate spatial information in LULC, how we can extract using machine learning and the computer science capabilities. Likewise, the vegetation is so important, and I have published in 2022. This is a normalized density vegetation index threshold-based urban green space mapping from Sentinel-TA at the local government area level of Victoria, Australia, with my postdoc again here. And in this particular study, what we have done is we map all the local government areas You can see here Sydney, which is New South Wales, Queensland, Northern Territory, South Australia, Western Australia, and Victoria. And it's really zoomed in there with Victoria. And what we have done, not only we map, we propose the urban green space index. That is like per capita income per head. What is the urban greenness in that population? We make the cross of demography with the greenness. For example, in each of the LGA, what is the population and what is the share of the greenness they are having? Whether we need to increase the greenness in that particular area or they are okay. That was the main cross. And for that, we mapped, again, this is remotely without visiting the site, NDVI map and histogram of NDVI values showing the distribution of the city of Melbourne. And this is the framework that we have done. We have image, we classify non-vegetation and vegetation in level 1, and level 2, we map the shrub and trees. In level 3, we classify those vegetation into stressed and healthy by providing the threshold values. And what we come up is this. In those 3 different classification levels for city of Melbourne, level 1 classification, which is A, you can see in the top left, and B is level 2 classification, C is level 3A classification, D is level 3B classification. This level contains 2 classifications, level 3 and 3B, for shrub and trees. So if you go back, so this is what I'm saying by level, level 1, level 2, level 3. Now, so this is the urban building trees. Now let's have a look in the building footprint. In the building footprint space, we use again publicly available data sets, and there are issues with data sets, and we apply the frameworks like teacher-student training framework, open mutual learning, and deep mutual learning. So maybe it is more interesting to computer science colleagues. And we synthesize and we visualize from different frameworks. So why we need to do building footprint extraction? This is a representative example. When we look into literature, we see that 33% of the literature is showing research on building footprints from across the world. Yes, we are extracting road center line, we are extracting urban land cover, we are extracting impervious surface, we are extracting water, and we are extracting trees and slums and all that. But building has fairly large scale. Even we are having shelter and we need buildings. That orthogonal image and label data are used using deep learning model. But that CNNs and EDNs are widely used, as we know, and then we published. It was actually accepted a week ago, even less than a week, 11th of July, and it is a preproof which is publicly available. So please have a look. This is my PhD student who is in his 3rd year, and we publish not only this work, what we recommended in this work is how to start with deep learning and what are the data sets, how we can access different GitHub and all those things we provided as extra resources. After conclusion, we included a section how to start with deep learning from new researchers. Because the way we want to do research is replicable. If the research is not replicable and useful by other scientists, then there is no point of putting all the money and investing in publishing if that is not replicable by, let's say, we are doing research in Australia, not replicable in Europe, or you are doing research in Europe and not replicable in Australia. Yes, we have to tweak the local variables, but it should be to some extent replicable. That is why we please have a look at that. We have done that, and we provided the advantage and disadvantage of this as well. And not only are some research, global industries are using low latency lightweight models are in demand. For example, Apple, Facebook, and Google, Alibaba, all these giant industries, they're using these low latency lightweight models. For example, Apple is using mobile one, Meta is using FreeNet, Google is using EfficientNet. Why I'm presenting this, why we tested this in this particular work is heavyweight methods are computationally expensive. And even with high-performing computation, we have to wait weeks and weeks. And to get a similar result, we can use low latency lightweight models. That's how the industries are using, and we use this in our research. So for that, we have building data products. Microsoft has some data. Likewise, OpenStreetMap, we have data sets. And we have JScape, which is a study in industry, we have data sets. And S3 has data sets, and Google has data sets. And these are incomplete. And we tested in one of the study areas from Sydney, which is Chatswood. And then Earth observation image products are there from Google Maps. You can see here from OpenStreetMap, Microsoft, and JScape, we overlay it. And as I said, we have uncertainty and errors in those products, which you can see how these are not lining up. So for that, we tested with deep learning and CNN how it will improve. And for that, the question we proposed for this particular work is, can we achieve accurate building footprint extraction from lightweight models that are being used by the industry and currently available in open data products? We tested with deep neural learning, which is multiple student networks are collaboratively distilled from a teacher with larger knowledge base. And originally a method for model compression, this one. And we adopted deep neural learning as a method for addressing the misalignment of levels and images into off-node source imagery. For that, we submitted and published in August 2023 in California. We presented and we added on top of that work. What we have added in this particular work is open mutual learning. For that, you can see this is from 2023, and then we added different data sets like this. So you have a question now in your head, what is the difference between deep mutual learning and open mutual learning? So let's have a look. We apply the penalty, we apply the weight, and then the softmax is the popular method in calculating weight, and we did this. So this is a difference. So open mutual learning is basically teacher, student, we aggregate the incompleteness of data. But in the deep mutual learning, we average. So that's the difference. When you see three different students here, the loss functions are aggregated using incompleteness of the data, but the here loss functions are averaged, and the knowledge is distilled. Each student is distilled on different data in open mutual learning, while in deep mutual learning, all the students are distilled on the same data. So, for example, what we do is, with the data sets, when we think of a framework of teacher is student, teacher is always knowledgeable and experienced. The student in that particular topic could be bright, could be talented, but not knowledgeable than teacher. So when we distill the knowledge, we apply these framework. And the loss function we calculated like this. The total loss is the dice loss and displacement loss. And we provided the results for this. The performance of teacher is always high, as I said before. And then students and accuracy measures were used to report this, like precision, recall, intersection over union, and F1 store. And you can see teacher and students data sets, sample 1, and all these issues are domain safe, incorrect, and incomplete GDP. Likewise, with different students with OML, we have different matrices and results. The mobile VIT is we're using lightweight models from industry to test the student with the highest scores in average. And despite the incomplete samples, the students distilled and OpenStreetMap could still produce high scores with help of other students. So these are some visualization of those results that we provide for these particular lightweight models. And the results that you can see, open mutual learning was found to perform better than deep mutual learning. The mobile VIT CNN consistently provided gains in all data sets. For OSM data, all students achieve higher scores than deep mutual learning. For Microsoft data, only mobile VIT offered better scores. The challenges and opportunities in Earth observation AI. With Earth observation data sets, there are problems with existing benchmark data sets. Off-node imagery and challenges with building features. Domain shift problem. When we say domain shift, as you know, you can't just translate the model from one location to other geographical location. We need to tweak the local variable. The small data set problem. So that is, the label data sets are very, very few. And aggregation of multiple nationwide data sets could provide a more complete data sets or even globally. So these are the data set perspective. Now, if we look from AI or computer science perspective on these observations, we can say CNNs are getting rid of pre and post processing. We don't need to do pre-processing of image and post-processing of image. So the intelligent methods can be used. Industries are showing us that. Larger networks do not necessarily increase the accuracy. So we can go with the lightweight model. We can go with some small models to have, let's say, similar levels. And lightweight and efficient networks are in demand. And CNNs are introduced in multiple disciplines, not only in observation or physics or geophysical parameter extraction or computer science. These are being used in economics to psychology. CNNs are more explainable, not any more black box. If you look into, let's say, some physical scientists, they might say, oh, this is a black box, you can't explain everything. But the results are providing very accurate one you have to trust, because industries are doing that. Like Apple or Google or Facebook, they're providing that. So conclusions from the tested intelligent methods, that what we can conclude that is accurate building extraction can be leveraged from available lightweight models and open data sets. When I say lightweight models, these are promising and efficiency gains in the building equipment extraction methods. And these are some of the observations we did with OML while we are distilling the knowledge. And even incomplete OSM building data set provided performance gains, then we can use more complete data sets from Microsoft and GSK. The tested methods can be used in different urban environments with image data as well as label data available. For example, what we want to use here. Having said that, there are some limitations. Knowledge distillation is a model compression technique. For example, smaller students may have limited representation capacity. Always students are learning. The students do not achieve higher scores than teachers. And students may overfit in small data sets. What are the ways forward that we can think of? Extensive evaluation of open mutual learning with robust cross-validation. Open mutual kind of sharing the resources, sharing the knowledge, and distilling the knowledge. Exploring the potential of Microsoft building data sets and improving log segregation using the evaluation scope, for example, IU to analyze the students. Future directions in building equipment research that we observe from all these 3 years of work, and this is a clear need for a special ecosystem that constitute a conceptual framework. Operational framework, including reality capture, is recommended, and operational framework should be able to embrace use cases considering data quality, completeness, integrity, and data volume, easy for labeling and training for accurate, precise, and robust spatial information. Such spatial information can be used for environmental sustainability and city planning. So this is could be the future directions in building as well as other urban feature extraction. So where are we heading in this place? So hopefully this will be displayed there. Let's have a look. It's not coming there, but what I suggest is please. Copy.
Try to click directly. Try to click. No. Okay, it works.
Yeah, but
no, because you don't see because you have to share this. You have to share this. No.
that's fine. That's just to show that link and people can copy and paste.
Okay. Do you see? Okay.
Oh, thank you.
Start again.
Yeah. So this is to show from European Space Agency how they are trying to make digital twin Earth from last 3 or 4 years. And what you can see out there in the physical world, they are trying to capture the digital format. And they are putting all the resources, most of the resources in digital twin Earth. For that, I suggest you to have a look. What this will do is this will help visualize and forecast natural human activity on the planet. And if you look into the examples, like for example, Singapore has developed the digital twin, and Germany has developed for different cities the digital twin. So this will help for the decision makers and support people in need. If there is something happening in the location, they can monitor from the table, from the office, and support people. So this is the concept European Space Agency is putting into. I will close this, and then hopefully we can go back to the slide and say again. Again, I have to say the slides. Bear with me, a few slides there, not many. Okay. Because of the language problem, you know, if it was English, I could have done it. And I need your help. Thank you.
No, you're welcome. Now I suppose that again.
Yeah. Sorry.
I have to switch again.
Yeah, nearly there. I'll go there. Right, there. And then this is a journey that we are doing from paper map to digital twin. If you remember 15 years back when we were driving in the city, we were using paper map. Now forget about that. No one is using paper map. Everyone is using navigation with these gadgets. So that is another digital twin that we are making, right? So this is, when I say digital twin, this is evolving terminology, and this can be done from landscape to human health. If you look into health system, people are developing the digital twin of different body systems. So this is evolving, and we shouldn't confuse with this from paper map to digital to 3D to SD, high definition light, and to endo, and the digital twin. So that is what we are discussing in every display. Hopefully this will display. Yeah. So this shows the things that we're doing with the digital things again. Maybe I need help. It is okay. Now, with that, that scale of landscape to planetary scale, now I would like to show a couple of examples. Let's say, let's focus on the left one, top left. What we're doing here is live traffic we are monitoring. You can see here with different color where is what we see in our gadgets when we're driving. red color, green color, yellow color, depending on the density of the traffic, live traffic, right? So that we are capturing here. And here live satellite image that you can see. And here live CCTV in the Victorian roads that we are capturing and providing interviews. And you can see here in the left, the CCTV. From there, the data are captured. And in the right, live tram. You can see the trams are moving around and we are capturing that. So these are the form of digital twin. So it has multiple levels and multiple acquisition of data sets in near real time. There is a time delay, but see the resources, how much we need to put. So we need to prioritize. We need to, depending on the geolocation, depending on the territory, we need to develop a digital twin of what we need. It is very hard to develop everything in one, but we can start. Live data, integration, analysis, and visualization. So I'd like to acknowledge the data providers, model providers, also the AI research group, and PhD students. With that, I'll leave the talk and I'll open for conversation and questions. Thank you very much.
It's close, not to have also the opportunity to the remotely connected people. We can break the presentation. Stop the
Stop sharing.
stop sharing. To be better in this way. Okay. Thank you, Jagannath, for your inspiring presentation. So, see it also that you introduced us your construction of your university and also interesting you can in the future. Okay. Now, question from the audience in presence. Student, otherwise we start with the discussion later other ideas and we can propose some things. Okay. We can start. I asked the discussant also come here because you do the microphone. Okay. Because the other the remotely connected can see you when you send just the camera is there. Probably ask to Guido, Giuliano, or one of them. So
thank you for this very interesting presentation. One comment, my first comment is that this is a very exciting direction in which the engineer profession should go, because I'm very impressed when you saw the courses in our degree, in our master degree. There are a lot of artificial intelligence, informatics, and so on. And I think it's a little bit a revolution with respect to the traditional engineering profession that probably you study in your work. This is my first comment on the organization of your study. The second is a question related to, you mentioned that you work with, of course, we need high spatial resolution from satellite data because you are looking at building and so on. And you try to use also synthetic radar aperture measurements, because as you know, there is a very high spatial resolution that can improve this kind of research that you are doing.
Thank you very much for your observation. I will on the engineering tradition because I agree with this kind of challenge. That's why we like to offer to the world where we are heading to this age, we need to see in a more kind of maybe radical way. So we are practicing the digital things, but we need to train our people instead of haphazardly using the tools and methods. It is a systematic
Closer to the microphone.
sorry. Systematic training to the new generation of engineers. So that's the reason why we brainstorm and propose this course. Thank you for that. Now, the second question is about very high synthetic operator radar or geophysical parameter extraction. Is we're using. I haven't presented a couple of examples here. Some of my PhD students are using for soil moisture extraction. For example, soil moisture, if we can have in certain depths, then we better understand what are the crop activities or how we can address some of the food security problem. For example, when we are having knowledge of soil by using synthetic aperture radar, then we can enter to food policy and food security. So we are doing that. But I have presented many important applications I learned on within the project. Yes, that is a great area to go from the soil moisture perspective. Thank you.
If I can close, I'm very happy that we have the past, not the current director of the School of Engineering, in the future director of Department of Engineering, because the current director, this is one of the points that his point related to the new figure of the engineer, and I think that also for the new director, this would be a very interesting suggestion in how we have to rethink our department and our lecture for the degree of engineering. Thank you.
Okay, the current director.
Okay, thank you for this presentation. I have one technical question and comment. The technical question is, the machine learning, the main problem is the generalization problem. And what would be in this situation the behavior of the tool in case the environment is changing quite fast? In case, say, there is some new organization in the area, and so on. But the second is just the curiosity. In Europe, the system now is that all the data from satellites are for free, because we have a competitive system, is the European system for approximation. So you can go to the platform and you can get the data for free. But the actual in Australia, the Australian satellite, the data are for free, or there is still some policy where some restriction of the policy for the data. So what's your opinion about the quality of the data in the open system and in the Google and Apple and so on? Thank you.
Thank you very much. This is a very good observation. As I presented, the question is about the data quality of European image and the Australian image in the rest of the world. How we can make opinion on the quality of image data. That, in my observation from my experience of all my career, what we need to acknowledge is all the data sets that we receive will come with some uncertainty and error. it is very hard to have the perfect data sets. But having said that, in Australia, what we're doing is we are making a pre-processing and providing the analysis-ready data sets, what we call analysis-ready. The PhD student or researchers, they don't have to go for quality assurance of data. So we are freely making available from Geoscience Australia the data queue, where you can download the data sets by running a single line code in your API and get the data sets which are analysis-ready data sets. And in terms of my opinion on European data sets quality, we always use European data sets like, for example, Sentinel-1, Sentinel-2, that I showed about the tree mapping and one way environment mapping for NDI, as well as for others that we use Sentinel-2. And for the radar one, as Professor asked before, we use Sentinel-1. So that means also the basic analysis are widely used, particularly from Europe. And we provide from Australia the analysis very purpose. Does that answer your question? Thank you.
Thank you. Yeah.
Thank you for your work and for showing us your results. So I was curious to ask you about the approach to the problems that are solved with techniques that you show, because you come from a region which is very different in terms of issues that we tackle, in terms of environmental perspectives and so on, from where we are right now. Because there's no that the research community here is also very much based on the territory and on the region where we are. So I was curious to know if there are specific problems that right now are driving your research more than others, and what are the future strategies to solve them. If you can give more comments about this, what is that working for the issue?
Thank you very much. If I understood correctly the question, this is all about tackling the environmental sustainability, and on top of what we're doing on urban inventories.
There is yes, the other camera is working. Probably you have to stay. No, you can look. Yeah. Or sitting. Also, do the.
Maybe I'll sit here. Sitting would be better for colleagues. Yeah, please. Maybe that's pretty good. See here. So the question is, colleague here, the road, about environmental sustainability and environmental degradation, how we do the research, it's all for the data sets and intelligent methods. So basically, I presented on urban building footprints and tree inventories. And the local governments, they are working on making machine learning and deep learning for tree inventories. Now, if we look into environmental problems, let's say water-related issues, water security, and water health, which is key for us. So how we monitor the health of water, right? And how we make assure to the public that the water is healthy to drink. But that a remote sensing is being used, which is a serious environmental, an important environmental problem. Likewise, air pollution. Air pollution is one of the identified issues, one of the three key global challenges the humanity is facing. For example, climate change, whether you like it or not. I mean, we are in this environment, all of us will agree that there is climate change. But when you go and talk with the business people, they might not agree with you. This is a natural process. How you can say that climate change is happening? Okay. But having said that, climate change, air pollution, and biodiversity loss. these three areas are a greater environmental theme. That question is directly, if I'm understanding correctly. So how we use these climate change, biodiversity loss, and air pollution monitoring and educating people is a challenge for everyone. And then for that, if you look at the United Nations, they are developing these sustainable development goals and proposing no left behind, all those things, right, as a policy. But from the science perspective, if we think of global rise, global sea level rise, for example, we know that sea level is rising. But if we have satellites from Greece to Italy, and we do have sustainable development goal monitoring satellites from China. So different countries are really serious in these three key areas of environmental sustainability, which actually we can use also the recent access of different products, or climate change issues, or biodiversity loss, and for air pollution, on top of water health and water quality issues. Does that answer?
It did. Thank you very much.
Okay. Maria.
So this is the very good arrangement, so that
Knowing you, I suppose that you will ask something about the spatial algorithm. I suppose not. Here, look. Must sit here.
First of all, Beniamino presented me as a very old friend. Not so
She's young. She's young. But old.
First of all, thank you for your presentation. You gave me images about also heritage, that is my topic. Here with us for the grades for also for observation for productions from natural risks and also from anthropic risks, for example, fires and from Pasco. And my question about the special analysis, and want to, before asking the next, do you think that the study of the spatial population is an intelligent because, for example, we talk about non-intelligent regression in machine. Okay, many years ago, there was regression and geographical regression. But today, the generated spatial population, I don't know if it is ignored or if it is completely integrated. And so it is that because it is or that.
So this is a very topical question, I would say. The question is for online colleagues. Just I would like to reiterate and reconfirm with Maria whether I understood correctly. There is autocorrelation with the spatial processes. What is happening out there is, let's say, this fire or any other phenomena that is happening out there in the real world. We need to consider the correlation or a spatial autocorrelation of different variables, and whether it is already considered in these models or not. That was the question, right? Yeah. So for that, absolutely, spatial autocorrelation is there. And when Maria,
Yes.
when Maria asked this question, I recall the first law of geography. From the Tobler's first law of geography, everything is related with everything. The near things are related more than the distant things. So if the variables or the phenomena are in distance, then the relationship is low or less, or the degree of the relationship is less. But if the variables are in close proximity, then the relationship is very high. So that says there is a spatial dependency. We can't study the things in isolation. The dependency, spatial dependency, is characterized by spatial autocorrelation, which we consider from the spatial data analytics perspective. When we consider different variables, we need to be looking into spatial autocorrelation. And some of the spatial data analytics tools, like spatial interpolation. If we know the value in a certain location, then we can use that to infer to greater geography. So with that, I think, yes, we can see a spatial interpolation in every project in this.
Also in deep learning and this intelligent.
Yes.
Okay. Okay. Thank you.
Thank you very much.
Thank you, Maria. Okay, now we can sit here. Okay, now we can start with the remotely friends that can ask something to Jagannath. Also, okay, I invited someone, one of them at the discussion, but also the other, if you want to ask something, we're welcome. Okay, we can start in this case with Dionysia, probably is okay, already prepared. Okay.
Hello. Hi. Can you hear me? Thank you. Thank you so much for not just an interesting presentation. I was thrilled about the ESA program on digital Earth. So, since I am a surveyor, there's this thing. In surveying language, we have to deal with the geoid, and the geoid has to do with the gravitation field, and then we also have to take in mind the sea level rise. And for all of these, we surveyors have a very strict code of working. We need, we're dependent on on-field measurements. So how can we integrate, or how can we facilitate all these on-field measurements that are necessary so as to produce the exact locations that are very, very important to you? Because in some cases, even for air pollution, even 2 meters can do a significant difference in earthquakes, in how the lava goes around. So how we can integrate the necessary field measurements and the rounds that they are needed with the open data, with the data from the industry on this, the space data, or any other data that I might not know.
Thank you very much. It's a very interesting question from surveying perspective. And just to reiterate that my first degree was in surveying. I'm a genetic engineer, and later on I focused more on remote sensing. I'm not a person from like ecologists or other people who are using remote sensing. So I understand the importance of measurement data. And what I think is this is very important. And then we need to provide the uncertainty of the data. When we measure anything, whether it is a millimeter accuracy or meter accuracy, depending on the fit or purpose, I mean, there will be time, there will be cost, there will be resource base for anything that we measure out there. As you say, if we want to go with genetic measurements, we are measuring millimeter accuracy, the deformation, right? The positioning, and the GPS location, and the GNSS measurements, and errors, and all that, whether it is relevant or not, let's say, for other applications. Absolutely, it is relevant, but sometimes what happens is fit for purpose come into play. So in that case, we need to say, I think the major data set will have these errors, or the range of errors and range of uncertainties, and this should be used within the confidence interval of this. So that sort of information in every data set will inform to people, and we will not be having issues with the misinformation, malinformation, and disinformation. That's the challenge in the present world that everyone is facing. Which is the right information that we are getting is a challenge, right? From the internet or any other things that we are getting, the user, they don't know. They can't just trust the supplier. But that, I think we need to move in that direction of being honest with uncertainty and error and the confidence interval of any measured data sets. Does that answer to some extent?
Yes, because many people do not understand that they think that we are persistent in accuracy, and then when we start to talk that depending on the type of data or the use of the data, you can have different type of accuracies. They look at us surveyors like we have come down from the moon. So we have to be honest that this data set can be used for that. For example, you showed the footprint of the buildings from various applications, and then as a surveyor, I understand the difference. So we have to make sure that everybody understands the range of the data that can be used and for which purpose.
Absolutely. Thank you very much.
Thank you so much.
Thank you, Dionysia. Okay. Dessislava, obviously, she works a lot on with artificial intelligence, and probably I can imagine that Jagannath with several ideas. Okay.
Yeah, actually, we are working on developing the first digital twin in Sofia. So we apply a wide range of algorithms, starting from statistic and machine learning through AI methods, and analyzing data coming from different sources, either images, but also sensor data and data coming from processes in the city. So my question is more related to artificial intelligence methods that you are using. So first, how you provide explainability of AI models. So are you using explainable AI? Because in order to communicate the results with stakeholders, we need to explain what kind of result we obtain actually to convince municipality, for example, to use our results to make decisions in the city. So the first question is about explainability. Then what level of detail we can achieve through applying CNN on observation data, because we can extract different details for the buildings. These are geometry of the rooftops or other elements of facades. And the last question is related to ICNN, because we can apply transformers, for example, and they can provide better performance than CNNs because their architecture is different.
Thank you, Desi. Nice to see you online. And that's a good question, actually, about explainability. So this is all about the evolving concepts, how to communicate to user. When we are thinking about general public or let's say expert user, we will be the audience. We should be able to explain in some sort of communication or language. But that explainability is evolving. For example, SAP+D, I'm sure you heard about the SAP+D index, the one index that in research people are using, right? For the explainability. So likewise, there are other indices where we can use quantitative terminology to explain the things. And for the visualization, for the explainability with qualitative things, we can use visualization. So what I suggest is, I'm using, for example, in the paper that I said, cover one in the Nature scientific report that we published, we use the SAP+D index to explain what we achieved from our model. And this is going on with all the researchers as well. And that is quantitative thing with the qualitative visualization. So that's the first question. The second question is all about why only CNNs, not transformers. You're right. Lightweight models that I presented from Apple or Google or Meta or Facebook. So these are the representative lightweight models. Now transformers are evolving and going on. Already we're using a transformer as well. And the way forward is transformer. I agree with you on that. And the third question, can you remind me? I forgot.
It was about the level of details of the features of the objects that you extract from the data.
Sure. So this is in relation to digital twin. Desi and the team are developing for Sofia, and how the objects are quantized and what is the level of detail the objects should be quantized in the digital twin. So for that, the question comes on granularity. So what is the Internet of Things that you are deploying, and what are the sensors you are deploying to capture the objects? For example, let's say in the digital twin, we want to capture the level of detail of bridge. And that bridge can be captured from satellite image. That bridge, if you want to capture the parts of the bridge, let's say not in bolts, and you might not be able to see from satellite image because of the resolution issue. But if you wanted to have that level of detail of not in bolts of the bridge, perhaps you should deploy the Internet of Things with very high resolution, the sensors that you can manufacture. In Australia, what we're doing is for the infrastructure health, we are deploying the Internet of Things sensors. We are asking our electrical engineering colleagues to manufacture the sensors that we provide the attributes to attach. And when we attach those attributes in the sensors, we can have the data in the numbers in our computers. So the object size, let's say, or the level of detail, it all depends on how we want to scan the things. And we agree on the level of detail, whether it is a level of detail LOD1 or LOD2 or LOD3 in the digital twin language. Does that answer your question?
Yes, thank you very much.
My pleasure.
Okay. Obviously, if the question of the other colleague stimulate other ideas for the previous colleague, obviously you are free to ask something again. We are happy to continue to discuss. Okay. Now there are two colleagues more related to my field of research, based on planner, but with framework on based on analysis, spatial analysis, etc., etc., etc. I asked to Sabrina Lai. There are questions.
Yeah, thank you, Beniamino. Thanks for your lecture. As a planner, and so not as a surveyor or a specialist in machine learning, I'm quite more interested in some of the aspects that are related to the usability of outcomes from your research. And the first question would be something that has to do with the future. What you presented requires lots of technical skills, really high quality skills, and that's the reason why probably you set up the master that you talked about at the beginning. Do you see a future in which also layman people can sort of play and use your results as we currently do with OpenStreetMaps or Google Maps or so on and so forth? And the second one has more to do with what I do and what I'm interested in as a planner. You mentioned the use of machine learning for tree segmentation, and you also mentioned that that's one of the fields in which your research group specializes. And what I would like to know is whether with such applications you only get kind of the spatial information, so where are the trees, how big they are, how tall they are, if you get this kind of size-related aspects, or also other kinds of information which are extremely useful for us, for the models that I use. For instance, age, species, health situation, and so on. Thank you so much.
Thank you very much. So there are two questions. I would like to summarize and for everyone's benefit, and then Sabrina will confirm. Thank you, Sabrina, for this question. The first question is how to access the publications of the data sets of the resources in a replicable manner and try to replicate in the another geography. So that was the question, right, Sabrina? First question.
Yeah, and the use of the layman people also.
Yeah, and then the second question was about not only spatial information, but beyond that, how we go for the trees, species, and every detail that what we experience as a human being for our environment. Is that the second question?
Yeah.
Thank you very much. So with the first question is, I presented a couple of work on tree measurements. What we can do is that's already available in the public domain. The data sets are in GitLab, and we can provide that if there is an issue of access. And that can be replicated in different geography and compare. I was discussing with Desi the other day. Perhaps we can replicate to, let's say, Sofia, and then compare with Melbourne, how we can replicate and map the trees and map the vegetation and bring that into digital twin and compare. So that can be done in a collaborative way. So for that, I'm very happy to provide any technical help needed from myself, from my team, and the data sets from SENEP2, from the European Union. We can have, and we can, in a couple of Zoom meetings, we can, replicate the method and get the results. So that can be done. And now the second question is all about going into not only tree canopy or tree measurement, how we go with the species level. For that, hyperspectral is the data set that we should be using. Hyperspectral, given we need very narrow bands spectral to go with the species. Because canopy mapping is kind of coarse mapping. But if we want to go with species, I suggest hyperspectral remote sensing would be the way to go. And beyond that, we can go with spectral and spatial information as well as semantic information. What is the spatial context? What is close to the tree, a building or road or any infrastructure? So which we can define any spatial context. Thank you very much. Does that cover your
question? It does. Thank you so much.
My pleasure.
Thank you, Sabrina. And the last one, obviously, not on the list, Gerardo Carpentieri.
Hi, thank you for your presentation. I appreciate a lot because you explained the usefulness of this type of technique in the application. Probably just a comment from my side, not a question, but probably the next step is to explain the technician, the public administration, the powerness of this usefulness of this technique to support the decision process. Because more or less in research activity now we appreciate the support of this technique in improve our analysis, but now the next step probably is to explain the technician and the administration that we support with our research the useful of this type of technique. I don't know if you agree with this.
Yeah, if I understood correctly, the secondment of the comment is about how we communicate these technical things to administrative people and other in the institution or in the entity that we work with. We are not working only with technical people. We need to convince the administration or the resources and all the infrastructure. I agree with that. I think perhaps I tried to cover from the industry examples like Apple or Google or Facebook, what they're providing as a lightweight model, or what we call in heavyweight, lightweight thing. We do have high performance computing But what happens is if we want to compute from high performance computing, it might take weeks and weeks, right? Or the heavyweight models. And that's the reason why we go with lightweight models. And as Desi previously identified, not only this, we can go with transformer. In research, the challenge is we always think new, right? In application or engineering, what we can do is we can apply what is out there in the market. In research, we want to innovate and we want to go for new things. And always it is challenging to communicate to administrators. But eventually, the whole philosophy of university is to creating new knowledge. And, we should be able to convince administrators with the philosophy of universities. We're not practicing what is out there in the market. We always think for the new. From that to what is out there in the market, we want to innovate. And we want to have, collaboration like this opportunity that Professor Murgante created with different countries from Bulgaria to Turkey to Italy to elsewhere, Greece. So we can start for the new things, new adventures, and new innovations, right? So that sort of language we have to use for the administrator, and they are good in administering the organizations, but their duty to accommodate the researchers or academicians' work habits and working culture is another thing we have to communicate, I think. Does that make sense?
Yeah.
Absolutely. I would agree with you. And also, it's more easy to discuss, face to face, but also inviting also the colleague because it's important for a group that can interact, creating other opportunities,
absolutely,
cooperation, and possibly to share researchers together.
Yeah.
Okay, it will be interesting. Okay, other questions from remotely or in the group? Okay, Simone. And I don't know if other colleagues connected remotely can ask something. Okay,
sure.
Okay, so thank you very much for your presentation, very interesting. And my question is related with the previous one by Maria Elisa. In your application, you use CNN. So this type of method work on a single pixel, on every pixel. So, but in your experience, there is some method that taking into account the neighborhood effect that analyze the context in which each pixel is the correlation between different pixels. Because I know that CNN don't take into account the topological relation between pixels. So in your experience, there are some methods that are able to, the methods that are more spatial explicit. So this is my question.
Absolutely. The question is all about just for the online fellows. Correct me if I'm wrong. In CNN, so what we do is we look for the pixel levels and the neighborhood, how we look at the relationship to neighborhood pixels. So basically, the philosophy of object, when we think of object out there, as a human being, what we do is we think of a car, we think of a tree, but we never think of a pixel of a car, pixel of a tree. But the building blocks is a pixel. So in an image, when we think of the building block of a car or tree or let's say house in the image or road is pixel. So the contiguous, homogeneous pixels, they form an object, right? So this is the concept of data acquisition in one spatial analysis unit. And what is the spatial analysis form? So unit and form, in my observation, what is the unit that we are talking? And what is the form of analysis we're doing, right? So when we try to characterize the relationship considering neighborhood, absolutely, we have to consider the neighborhood. The neighborhood relationship as a special context should be considered. And when we form an object, the end goal is object. Whether we do CNN or transformer or anything, that is the analytics we do. But at the end, we want to have a special information and we want to have a frontiers of what is out there in the real world, right? The outer boundary. We want to extract the building footprints, the frontiers or boundaries. We want to extract the canopy of the trees. We want to extract the roads. So let's say a vector in GIS language, we want to have a vector layer by considering the integrity of the neighborhood relationship. So that integrity of neighborhood relationship can be characterized, can be modeled using different matrices. For example, as the question was indicating how we do the, let's say, autocorrelation, spatial autocorrelation, whether it is Moran's-I or any other form of autocorrelation. For that, we can look at the point data and turn that into the object form. So this is all about, as I said, spatial analysis unit and the spatial analysis form, and looking into the spatial context from the neighborhood, whether the contiguous homogeneous pixels are forming an object. That make sense?
Probably it's a different way compared to the past to consider the special
Absolutely.
autocorrelation, because in the past years we need a new method to consider also spatial autocorrelation. Instead, now it is already integrated inside, for example, CFD.
Yeah, that's a very good observation, Maria. Yes, I agree. Yeah, it's not there, but I would say it is. We have to argue in a sense that neighborhood relationships need to be characterized and presented in one level.
Yes.
And then once we know the neighborhood or the special context is there, then we can form homogeneity and heterogeneity criteria. But that we need to develop the threshold, right? So how we define the homogeneity and heterogeneity is, again, threshold will come, right? In the image, when we capture the image, we can't separate every object. Images are like the real world. But when we want to have, let's say, road and building, the road can be overlapped with the building pixel. There is a mixed pixel problem in the image. But in the real world, there is no mixed pixel. In the real world, building and roads are clearly different. But in the image, they come with the mixed pixel, right? So that's why the neighborhood relationship is so important. It's not that.
Thank you. Thank you. Okay, other questions? No? So from the other correcting remotely? No? Okay. Thank you so much to Jagannath, but before closing, I asked also to everyone connected remotely to open the camera, and we will do a picture all together. Come here. Come here, a picture all together. Also, Floriana, open the camera. Okay. And also the other connected. Okay, come, everyone. Everyone. Sign the presentation.
You want me to stand up?
No, really. C'entriamo tutti? Ho preso online. Ok, grazie. Ok, grazie. Obviously, I have a picture of the front connected remotely. Okay, thank you so much for the time standing. It's happening for discussing all together and to be in touch, because I hope that we can make something interesting all together. Get a good group also for cooperating all together. Okay,
Thank you very much, Dr. Murgante, for this opportunity. And I'd like to thank everyone who are online as well as in the room. So let's create a be together and let's share the knowledge. As I said before, we're thinking about new things always in research, and we want to support the community, and we are in the same community of observation, geomatics, or spatial planning, or computer science. The computer science is so essential for developing insights, and let's work together on common interests, and that will create fun, more fun. Thank you very much.
Thank you.
I'll pass to